Hello, welcome. This video is for the semester one final to help you to study. This particular question is from Unit 6 on standard form and using the quadratic formula to solve for x. So we've got a problem here, 6x squared minus 10x minus 2. Want to make sure first that it's in standard form, which is that the squared term first, ax squared plus bx, this the x term, and then finally your constant plus c equals 0. It could be equal to y. It could be equal to f of x. We have it equal to 0 because we're looking for specifically the places. They call them zeros, or they call them the places where it crosses the x-axis or the x-intercepts. So we'll go ahead and leave it here as 0. The important thing is that you've got your squared term first, and then your x term, and then your constant, which we do. So it makes it easier to see that in this case, a equals 6, b equals negative 10, and c equals negative 2. And once we've identified those values, then we can plug them into our quadratic formula here. But the first thing we're going to do is find the discriminant. And so I'm going to just rewrite this, b squared minus 4ac, just copy it down. It's not under the radical, it doesn't include the radical, it's just the part underneath. B squared minus 4ac, which is b squared minus 4ac, and b is negative 10, a is 6, and c is negative 2. And this right here, you can just put that in your calculator and get a value, but I'm going to work through it, which is also a good idea. And then you can kind of check it in your calculator, see if you get the right thing. So negative 10 squared, a negative times a negative is a positive, that's a 100. And then I've got a negative here and a negative there, so those are going to multiply and give us a positive, so this is going to be added instead of subtracted. 4 times 6 is 24, times 2 would be 48. And so I've got 100 plus 48, which would be 148. Now, because that's, remember that you could have a positive, you have 0, you have negative for your discriminant, and if you have positive, you're going to get 2 real, 0, you're going to get 1 real, and if it's negative, you're going to get 2 non-real solutions. And so in this case, we know we're going to get 2 real solutions. So over here, I'm going to plug it in, my values. I'm going to copy it down again. I know I have it written right here. I'm going to copy it down again. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And we're going to write negative b plus or minus the square root over 2a. And the reason I left only those 3 blanks and I didn't put any of those extra blanks in there for b squared minus 4ac is that we've already calculated it. It's our 148. So I can put that in. Let's go ahead and put it in right here. That's my discriminant, b squared minus 4ac. This is the negative b, but b is negative 10, so I'm going to put negative 10 in here. And then a is 6. At this point, I'm going to simplify this out just a little bit. I'm going to put 10 plus the square root of 148 over 2 times 6, which is 12. And then over here is just the negative version. This is why it has 2 solutions. I've got 10 minus the square root of 148 over 2 times 6, 12. And so those are my 2 solutions. And what we want to do is simplify our radical. And so I'm going to say 148 and start breaking it into the prime numbers. Remember, the primes have exactly 2 factors: 2, 3, 5, 7, 11, 13, etc., etc. So those are the first few. And I'm going to see, can I break 148? Can I divide it by 2? Yes. I always start with the smallest and then just work my way up. 2 is we'll go into 148 because it's even, and the half of 148 would be 74, and then 2 will go into 74 because it's still even, and 2 goes into there. Let's see. I want to say 37 times. And with a little investigation, you could find that 37 is also prime. And so I would just say 37 goes into itself one time, and when you get to 1, you're done. Now, those are the prime factors. 2 times 2 times 37. And if you have a pair of 2's, those can come out as a single 2. And so the square root of 148 is the same as 2 times the square root of 37. This one does not have a pair, so it stays under the radical. But these, essentially, think about 2 times 2 is 4, and the square root of 4 is 2. So that's what happens here. So depending on the requirements of your teacher, you may end up with this as your final answer. 2 plus 2 root 37 over 12. And 10 minus 2 root 37 over 12. Depending on the requirements of what you're looking for, you might want to just go to whatever the decimal value here is. Or you also may be asked to simplify the square root. So the reason when I'm singing this, I hold this out all over 2a is that it's important you remember you have to divide all of it by 2a. So this is the same as 10 over 12 plus 2 root 37 also over 12. All of these terms get divided by 2a. And so same thing over here. This is 10 over 12, but here it's minus 2 root 37 over 12. And then I can simplify this. 2 will go into both 10 and 12, so that becomes 5, 6, plus, and 2 goes into itself. Obviously, it also goes to 12, so those cancel, leaving the square root of 37 over 6. And the same thing that would happen over here, then this would be 5, 6 minus root 37 over 6. And again, important to note that sometimes you might write your answer as 5 plus root 37 over 6, or 5 minus root 37 over 6, or there's some kind of decimal value that goes with this and also with this. And so those are things to keep in mind. Be prepared to simplify your radical down to at least this, or maybe down to one of these two values here. They're the same. The values are the same, but where you go with it depends on kind of what the requirements are of your teacher and what you're being asked for when you solve the problem. Keep studying, practice. You got this. Don't get frustrated. If you need help, please reach out and ask for help.